Okay. Now problem number 67 and 68, they don't need pen for calculation. It's very simple theoretical problem. Temperature dependence of resistance of copper and silicon in 300-400 K range. Copper being a conductor, you know what will happen in this particular case. You know the formula for the resistivity, and when the number of collisions takes place and the temperature increases, the number of collisions now will increase and the relaxation time now will get reduced, and that will lead to increase in resistivity of copper. But you know what happens in case of semiconductors? In case of semiconductors, there is an exponential increase in the free carriers. So the n term there, the increase there will be dominating. It will be dominating over the tau, that is the relaxation time, and there will be a reduction. This is the basic theory, you know, from NCERT, this particular thing. So the correct answer will be a linear increase in case of copper, but an exponential decrease in case of silicon, because silicon being a semiconductor, the formula goes as free carrier n is equal to n0 exponent minus Eg divided by 2 kT. So that formula will come into play, and this is obvious. Right. Okay, 68th question. Amplitude modulation, frequency modulation. You know what is done in amplitude modulation? The amplitude of the carriers change with respect to the message signal. In frequency modulation, you change the frequency of the carrier with respect to the message signal, keeping the amplitude constant. So obviously you have to pick up the correct answer, which is amplitude modulation. The amplitude of the high frequency carrier wave is made to vary in proportion to the amplitude of the audio signal. That is the correct answer. Does it require a pen? These are actually factual questions that you could pick them directly. All right, the next question is question number 69. Now this looks very simple, but indeed they have packed a lot of trickery into it. You see, what are they asking you? They are giving you half-lives of two radioactive elements, A and B, 20-minute and 40-minute respectively. Initially the samples have equal number of nuclei. So to begin with, at t equal to 0, the number is equal. This is n0 and n0. So both are, A and B are having the same number, A0. Now the half-lives of this, the t has a half-life. This half-life of A is 20-minute and this is 40-minute, right? TB and TA minute. And they want to know after 80 minutes the ratio of decayed numbers of A and B. Mind you, they don't want the remaining number, they want the decayed number. You know the formula is n, the number present to the original number, 1 by 2 t by t, right? So the time that has elapsed is 80 minutes. So actually 80 minutes by 2. For A, you will say NA that is surviving is N0 into N0 into how many half-lives? 4 half-lives. You put here, you get 1 by 16. So this is the number present now. So what is the number that is decayed? The decayed number will be N0 minus N0 by 16, that is equal to N0 by 15 N0 by 16. And similarly, if you do the calculation for B, 40 minutes. So how many half-lives are gone? 2 half-lives. So 2 half-life means NB would be N0 into 1 by 2 whole square will be 1 by 4, and the number will be N0 minus N0 by 4, that will be equal to 3 N0 by 4. Right? And what I can do is I can simply multiply this by 4 and I can multiply this by 4. So I get the 12 N0 divided by 16, and you can compare these two terms. So the number of Na to Nb that have decayed will be equal to 15 divided by 12, that is equal to 5 over 4. So the correct answer in this case would be 3. Okay, a lot of people would have got it wrong because you know, if the problem is too simple, people get carried away, you know, they get overexcited and they will think it is too simple. They will calculate 1 by 4 or 4 by 1 and write those answers. But you have to read clearly what is asked. Question is telling you samples have equal number of nuclei in the ratio of decayed numbers of A and B, not the remaining numbers, decayed number, right? So this is the way to go about it. Question number 70 is from Heat and Thermodynamics, and this question in IIT 1993, if you see the paper, you can get almost the same question with just a minute change in data. What is the change? The change is in the value of P. There in 1993 when the question was asked, they gave you the value as 2P0, P0 and V0, 2V0. Very common question. We discussed in the class many times these type of concepts. So you see, what is the problem telling you? It is giving you a graph that is, this value is given to you as 2P0, this value is given to you as P0, this is obviously P, and then you have here V0 and this quantity is 2V0, right? And obviously this is V. So straight away, if you look at this whole thing, you can see that you have a process coming into play here, 2P0 V0 and this is 2V0 P0. So at this point temperature and the temperature here would be same, but that does not guarantee that temperature everywhere here will be same, because you know a typical isotherm is of this shape, whereas this is straight line. But any straight line you can represent it by the equation y is equal to mx plus c. So you can write the equation going here, that will be P y equal to m. So m is your minus mx, x is v plus c. And let us calculate the value of m and c. So let us put the values for this. This will be 2P0 is equal to minus m into v is here v0 plus c. Similarly, if you go for this value, this will be P0 minus m into 2V0 plus c. Right? If you do this minus, plus and minus, you get rid of this term and you get P0 by V0 is equal to m. Right? This will be 2V0 minus V0, that will be V0 and P0 V0 by m. Substitute this value out here and you get P is equal to, or you substitute it here, 2P0 is equal to minus, so minus P0 V0 into V0 plus C, right? P0 V0 by C. So you lose this with this and you get 3P0 as your C. So what all this has reduced to, if you look at it, all this is reduced to a simple equation, and the equation here will be P equal to, and you calculated minus P0 by V0 V, and then the value corresponding to C is 3P0, right? So you have this value of P, but you know one thing, PV is nRT. PV is nRT was standard gas equation. Take the value of P, put it here. You get minus P0 V0 into V plus 3P0 into V is equal to nR and T, right? So what do you get here? Minus P0 V0 V square plus 3P0 V is equal to nR T. Because we are asked the maxima, we'll just derivate it. First derivative of dt by dv should be 0. So it's convenient to do dv by dt. I go for that. Minus P0 V0 into 2V dv by dt. This term will be 3P0 dv by dt. And this term will be nR1. Okay. So let us do a little bit of shifting and see what you get out here for dt by dv. Let us do that. So if dt by dv, I have to do, what I can do first is I can write these terms like this. This term will be minus 2v minus 2v dv by dt. I am taking common from here, or what I can do is dt by dv is set is to be made 0, no? So let us take this dt term here and dv term here. So you get dt over dv, okay? And what are you left with here is basically minus 2P0V, 2P0V divided by V0, and here you will be left with 3P0, and this whole term out here will be divided by nR. Okay, shift it here, dt I have taken here, dv I have taken here, but this term has to reduce to 0 for the maxima. So this term nR will come to 0, and you get what? You get minus 2P0V plus 3P0V0 should be equal to 0. So this P0 you can lose from here, and you can get the value corresponding to V. So V will become equal to 3V0 by 2. I think it is obvious. Take it there, minus will cancel 3V0 by 2. So this value of volume is going to give you what? It is going to give you the maximum for the temperature. And this value, you have to calculate the result. So let us find out what the answer would be by putting the value there for V. Let us find out what are we going to get. So our standing equation came out somewhere here. So P would be equal to minus P0 V0 minus P0 V0, okay, P0 V0, and then this term you know is equal to 3V0 by 2 now, plus this term is 3P0, right? So you V0 and V0 you can lose, and you can get the value going for P. P would be equal to minus 3P0 by 2, and 3 to this becomes 3P0 by 2, right? 3P0 by 2, and temperature that corresponds to this will be 3V0 by 2, and from here you get 3P0 by 2 is equal to nRT. So T max now can be calculated as 9P0V0 for nR. This will be your temperature maximum. There's an answer for this, I think. You can see the option number 4 is correct. So you get 4 is correct answer for the problem. Okay, right.